Alright, today we're going to be going over the questions that we had on our Mastering Chemistry weekly quiz and one slide of notes. First question has us doing a stoichiometry problem that's already balanced for us, so that's going to be really nice. Automotive airbags inflate while sodium azide decomposes explosively for its contents. Now, some of you might have experienced this at one time in your life. However, this is how it all works. But this is actually saying how much is already in your airbag based on 22 grams of nitrogen being formed. So what we'll look at is we'll take our 22 grams of nitrogen and convert that into moles. I'm going to do some simple calculation and utilize the fact that I know that it is 28.02 grams of nitrogen 2 for 1 mole of nitrogen 2. I then need to convert that into moles of sodium azide. So then I need to have my moles, and that is incorrect. I need to have that into moles of nitrogen, and if remember, we should always utilize the numbers that are in the balanced chemical reaction for our stoichiometric ratio, or mole to mole ratio, into 2 moles of sodium azide. See that the ratios of those cancel out. Now the next step is one that a lot of times students get to this point and they just kind of start working and they forget to do the molar mass of our what we want out of this, and that would require us to look and say I have 1 sodium, 22.99, and nitrogen is 3 times 14.01. Something that, again, a lot of students will forget, but hopefully you remember at some point so that you do actually end up doing this. And it is done. Or it should be 42 from 43. Let's erase that. And I have 42.03. Add those together. I know some of you will probably have a calculator, which is probably very handy. However, I don't have a calculator handy. Plus, doing some things in our head that's not so bad, or at least longhand. Then need to multiply grams per mole of my sodium azide, mole of sodium azide. I then plug those into my calculator, which I'm actually going to grab now. And when I multiply across the top, and then multiply across the bottom, you should get an answer of 34.0, and just go 4 significant digits of 3 grams of sodium azide, as we have there. The second question has magnesium burns in air with a dazzling brilliance. This is one that you actually did in the class, in the lab, about a week or so ago. And we are converting from moles to moles. So this one isn't as hard as it might seem. A lot of times students want to try and convert your moles into grams, but it's not necessary. Again, all we need to worry about is just those things, because all they're asking for is just the moles, and that's what we're given. So I need to have my 2 moles of magnesium to 1 mole of oxygen. That gives me 1.02 moles of O2. So very simple, not a lot of calculations. It's a lot of it comes down to being able to read and not going through and trying to convert your moles of magnesium into grams of magnesium just to convert it back out again. This question can be looked at a number of different ways. You can actually do the full all-out calculations, or you can kind of look at some of the comparison and do some comparisons. Based on the reaction, how many moles of carbon monoxide can be obtained with starting with 8 moles of methane? Well, I can see that I have 2 molecules of methane, or also can be looked at as 2 moles of methane. That will make 2 moles of carbon monoxide. Knowing that these 2 are connected, it says how many moles of carbon can be obtained with starting with that. You are going to go with under the impression that you can have enough water to make more. It doesn't say anything about a limiting reactant of any sort. So because that, since they're both 2 to 2, if you want 8 moles, well, you can do the math and have 2 moles and 2 moles. And you'll find that you will want and or be able to get 8 moles of carbon monoxide. This one's a little bit different, but very similar, where you have options on how you solve for it. Based on the reaction, you start with 8 moles of methane. How many moles of hydrogen can be produced? Well, if I start with 2 moles of methane, and I can count 1, 2, 3, 4, 5, 6. If I'm starting with 4 times the amount of methane, I should have 4 times the amount of hydrogen. And therefore, you can go it as 6 times 4 to give you 24. Or we can go about it the other way, which might be a little longer. However, it is what it is. Now, if I did it this way, I'm seeing that I'm not getting the same answer. And this is the right answer. So sometimes you can reason yourself through that if you get through that. So I reasoned myself through it when I did it in Mastering Chemistry. And so I was able to kind of look at it and say there's 3 times as much in there, so I was able to go and get the right answer with that. Now the one problem that we have to do for notes today. The student goes in the laboratory and reacts 10 grams of silver nitrate with sodium chloride. The student recovers 0.246 grams of silver chloride product. What is the percent yield given? Now this is actually taken from my quantitative analysis. One of the first times I did this lab, one of my samples came out not so good. So let's see how well I did in a percent yield given. So again, because it's a stoichiometry problem, because they're 1-to-1, that's going to make life a lot easier. However, I am going to need to know my molar mass of both my silver nitrate and silver chloride. So I go through that process, venting that out and having oxygen. 1, 3 times, because Master in Chemistry likes to have it like this, that's why we'll keep it that way. And 107.87 gives me 107.87, 14.01, and let's see, 47.97, and I need to then add those up. After I add those up, I see that I have 169.85 grams per mole. Let's use a different color for the silver chloride. And silver chloride should be pretty simple. I get to use a 107.87. Chlorine is, because it's 1, I'm just going to not do that multiplication. 35.45, and then just add them together. After adding them together, I get 143.32 grams per mole of silver chloride. Make sure I label everything so I know what I'm dealing with for everything over here. Alright, this is again, how do we know that this is a percent yield? Well, one, it does say that, and it's not, it doesn't give us 2, it's not a limiting reactant because it doesn't give us 2 of our reactants. So we do have that going for us. And so now when we start putting this all together, we have to start all the way with our 10 grams of silver nitrate. I need to convert that to moles utilizing my molar mass that I calculated earlier. Grams mole. Nitrate there. See that those ratios cancel out to 1. We then need to convert to moles using our mole to mole ratio, which again for this problem is 1-to-1. Then need to convert to grams using my molar mass that I calculated earlier. And of course I ran out of room, so I won't cancel out those. And we'll go from there. Alright, now I need to do my calculation. First round of calculations. And after that, I can see that my calculations, I should have got 8.4, and we'll go 3 significant digits, 4 grams of silver chloride. Now that doesn't look very good when it comes to comes to putting anything together. So we need to make some room here. Well, so now that's my theoretical, and that's the part that I think a lot of us are going to need to understand. That's my theoretical. And let's go theoretical. All right. Theoretical. My actual is the other, and so I need to put those two into two parts and say my actual, what I found in the lab, and grams of silver chloride. Divide that by my actual, my theoretical, sorry. This is not going to look very good, and sometimes it's okay because I did not do well in this lab. First time through, I need to make sure that those are divided. Dividing those, utilizing again my full calculator readouts for everything. 291.5, multiply that by 100, and I get 2.92%. Needless to say, I did not do very well on this lab, and therefore I needed to redo it, which I did 2 other times, just to get a reasonable grade on this lab. So that is all that we have for today. Now please make sure that you utilize the time wisely for the rest of the hour.